Okay, new one. Okay, so now this is created. We can start the session. Hmm. So you can see my screen, right? My tab.
Yes, I can see the screen.
Okay. So now let's get started about low-level design. How do we approach any low-level design? How is a low-level design different from a high-level design? Do you know? In low-level design, we directly deals with the classes, objects, and the low-level coding implementation. Whatever you are going to
Okay.
deploy into the application server. So we deal with that, and in high level we talk about the high level system architecture, the components, how are they
Mm-hmm.
going to communicate, the database layer, and all that, right? So now, if you see any low level design, we generally we we try to use various design patterns that are used there. Then we also use solid principles that are used there, and then various mechanisms like you have keep it stupid and simple and all that, right? So you
Mm-hmm.
can read more about that those
Drive.
from the web. So let's start designing a system which is a parking lot. That's a very generic and the most famous low-level design system design question.
Mm-hmm.
So the first approach here should be is to clear the expectations from the interview. What all things are we going to support? This is what we call the functional requirements.
Okay.
Okay, so that means these are the things that you will definitely need it. Okay, from so in a low-level design interview, consider your interviewer as a client, and you are the one who is going to develop the product for your client. That means for the interview. Okay,
Mm-hmm.
so that means your client will need this facility. What is your client does not know anything about the domain or anything about the application service layer and all that.
Mm-hmm.
He or she is just concerned of the functionality whatever that person has asked. So what all functionalities can be there in parking lot? I also need your suggestions. Okay, so first and foremost, car parking of car, right?
Yes.
Parking of two-wheeler we can call as a vehicles, parking of vehicles. It can be either two-wheeler, three-wheeler, or four-wheeler, right? Depending
So
on
we are
the
assuming like it's just like we are talking just about a vehicle. It can be anything. One, two,
right,
or three, three-wheeler, four-wheeler, anything.
three-wheeler, four-wheeler, anything, right? It's
Okay.
a parking of. So this is the basic functionality we will provide. Any other functionality
Mhm.
which you think can be useful for us? Parking
Yes.
of vehicle is one.
I
Then
guess we'll have to ask them whether
mhm,
uh, they need a separate space for handicap,
right.
or maybe that's not
Parking of
relevant for our.
vehicles for two, three-wheelers or handicap, we can also extend it. So basically, it should be extensible for different types of vehicle, right? This should be
Mhm.
extensible. So this is one features that our parking lot should support. Then what all features? It should have one
Also, it
end.
should have
It's going to
ticketing
have
feature,
a pardon,
like payment feature or.
right? So basically,
Mhm.
so basically on exit, it will first talk about entry. So
Okay. Yeah.
so how many entrance gate can be there,
Mhm.
right? So there can be one or it can be extensible, one or more entrance gate. Same goes with exit also, right?
Uh,
Then upon exit, upon entry, you will be assigned a ticket.
mhm.
Entry, you will be assigned a ticket, and upon exit, you will be asked for the payment, right? And payment will
Right.
be basis of hourly based, or it can be on the basis of vehicle also, and then other it should be extensible to different types that will
Mhm.
support. Then what all features generally a parking lot have? Do you think of anything else? So these are the so try to minimize the functional requirements so that you can cover at least because this is something that you are going to need it anyhow,
Mhm.
right? So all the
Yes.
different types of vehicles we have covered, exit and all that. Okay, and then you can also discuss about non-functional requirement. That means these are not something that they are looking forward, but if time permits, we can also cover this one. It should be a highly scalable and extensible, something that is very generic, highly scalable and extensible and all
Mm-hmm.
that. Okay, let's park this for some time. So now let's build this system. Okay, now how do we approach a low-level design? Is mostly you are given a this thing your requirements, right? Now first approach, think of the way the system would interact, right? So now let's
mm,
visualize how the system would interact over here, right? So just think in this way. So you are a client, okay? You came with a wheel, sorry, you
mm,
came with a vehicle, right? And then this is your parking lot. You came with a vehicle, you are at the, this is your entrance gate. So this is just try to visualize the system and then think of
mm.
what all components are involved over here. We will write down what all components are involved. Components are basically your entities which
Okay.
are involved into this system. So you can think of
Mm,
that, right? So this is a user, this is one component, just list it down. Okay, then what user comes, they come with a vehicle, right?
mm,
So let's list it down. They come with a vehicle, and then they come at the entry gate. So entrance gate can be another. You can think of this as a
mm,
verb
mm,
which you can think of, and then you can list those down. These will be your components that will be interacting to the system.
mm,
Okay,
mm.
so you can have entrance gate, and then at the entrance gate, what features are you going to provide? You are going to provide assign a ticket,
Ticketing. Yeah.
right? So you can write it down. This is basically your function of entrance gate. So
Mm,
entrance
mm.
gate function is assign the ticket. User function, no
Okay.
functionality of user. Then vehicle functional, no functionality of user. Sorry, vehicle. Entrance gate functionality has, it has to assign the ticket to whatever the thing is, right? And then you
Mm,
have
mm,
ticket as the component into your system, right?
mm,
So ticket would be another component. A ticket is assigned to you. Then what you do, you are given a parking spot, right?
mm,
Parking spot can be of many types. It can be of two-wheeler, three-wheeler, four-wheeler. Vehicle can be of two-wheeler, three-wheeler. On the basis of that, you'll be assigned a parking spot. And then,
Can you
um,
drag your screen up?
yeah, just a minute. Yeah, so there can be
Mm,
this one. Parking spot to it can be of various on the basis of wheels, right? What else we can provide on this? You can see the
so I'm
screen, right?
thinking. Yeah.
Mhm. Okay, so and then what will happen? A parking spot is being provided. Just close your eyes and think. A parking spot has been provided. You go there and park the vehicle, and
Mm.
then what do you do? You
So
park the
so
vehicle
what's happening
after
is
some.
the
Mhm.
timer is running. So a timer is
Yeah,
running, and
that is fine.
you
You
can
can get
count
it
off.
from the
Yeah.
entry and exit
Exit.
time
Yeah.
timer
Yeah.
and all that we won't need, right?
Yeah. Yeah. Yeah.
Because timer you can get from the whenever the person is exiting, and
Exiting.
the
Yeah.
person
Correct.
when it is
Entry minus.
entering, we
Yeah.
can just
Yeah. Exit
subtract it,
minus
we can
exit. Yeah.
get that time, right?
Yeah.
So there is one exit gate that is involved over here, right?
Hmm.
And then parking space is speed. So basically it what it will do is it unassign parking
Unassigned
spot.
ticket.
There
Hmm.
are various functionalities which is provided by the exit gate. It unassigns the parking spot,
Hmm.
and this is one of the, so we'll talk about the core components, not the unnecessary component, right? So if
Hmm.
you see high level, these are the various components that are involved into our system. So now let's design each and every components out of this, right? So you, there are two approaches. One is this thing. One is a low bottom up, and one is a top down. So you can approach this low level design in any way. Okay, bottom up is basically which are the lowest level entity in your system. It can be a parking spot, right? That's the lowest level,
Hmm.
and on the highest level it can be the user entering a vehicle. That's the first component that is happening, right? So you can
Hmm.
design a
Hmm.
system in any way, right? So let's talk about let's start designing our class diagrams for this one. So you will heard of two things. One is class diagram. Mostly we deal with class diagram. So there's class diagram and there is a use case diagram also. Okay, so use case diagram lists down all the functionality. What's the functionality of entrance gate? It assigns the tickets. Then what's the functionality of exit gate? It unassigns the parking spot. And
Hmm.
then what it does is it also calculates the payments, right? At the exit gate, the
Hmm. Hmm.
functionality is being provided, right? Okay, so these are the core. Uh, I mean, these are the things that you need to consider while designing this low-level system.
Hmm. Hmm.
Okay,
Hmm.
so now can you see the number six now? Can you see the
Yes.
red line?
But yeah, I can see the red line.
Why it is shown there? Okay, let's forget about it.
Yeah.
Okay, so now let's design this system. Okay, so first let's pick up the lowest one, which is the parking spot. It can be, so now parking spot. Let's start designing the system. Just a minute. So first is the parking spot. So from where I'm getting this, I'm getting it from here, from the
Mm-hmm.
components entities that I've written over here, right? From
Mm-hmm.
here I'm writing it down.
So the
Mhm.
components are ultimately going to be converted to classes.
Correct, exactly. Components or
Okay.
entities are going to be converted into classes. Correct,
Okay.
that's the correct terminology you have used. And now this can be extended after some time. This is the high level
Mm-hmm.
overview that we have decided till now. There will be another entity that will be payment. Payment you can make it
Correct.
via cash, CAD, or cash online,
Mm-hmm.
right? So there would be another that we have missed, cash, card, cash, online. So let's devise for this one. So now let's start building these components. Okay, the first one is the parking spot, right? Let's do. So parking spot. Okay, now parking spot can be of different types, right? Two wheeler spot, three wheeler spot, four wheeler spot, right?
Mm.
So we can make the parking spot as the this thing,
As a class.
as an abstract class.
Mm-hmm.
Okay,
Correct.
which can be extended. So what
Mm-hmm.
all does the parking spot will have? It will have its own ID, right? Just think of what all things a parking
Mm-hmm.
spot can have. A parking spot will have a is empty or
Size.
is available or not.
Yeah.
If it's
I don't know.
available or
Can
not,
we
it would be of
should we
type
consider
boolean.
size?
Pardon?
Should we
No, no,
consider
size.
size
We
as
are
a
not
parameter? It
concerned.
doesn't matter.
If you
Yeah.
see, there's no correlation of size and everything, right?
Mm-hmm.
There's no need of size, right? If it's available or not, and then talk only of the components that are involved of the functional requirements. Okay, if it's
Okay.
available or not.
Okay. Okay.
And
Mm.
what else do we have in a parking spot? If it's empty, if there is, and a parking spot is generally associated with a price that is has, right?
Mm-hmm.
So is available and then a particular price that is has. I'm drawing the class diagram over
Yeah.
here. So you can consider is
And
as a base class or an abstract class.
mm-hmm.
Okay, now this parking spot can be extended by two-wheeler parking spot, three-wheeler parking spot, and many more.
Mm.
Right? Similarly, okay. And parking spot, does it has any vehicle or not? And this is the type vehicle,
But
right?
aren't we assuming like, acha, acha, we are
Mhm,
so vehicle would
mhm.
include when it's
It would be
extended.
null. If it's empty, it would be null, right? Vehicle.
Yeah.
If it has vehicle, we'll just assign the vehicle. If it doesn't, it
So that would
mhm.
mean that vehicle will also be its own class, no?
Yeah, exactly. So vehicle
Mm.
is its own class. It's exactly. So it's again an abstract class. Vehicle.
So,
What
but
all things a vehicle has. Pardon?
for a functional parking lot, do we have to necessarily record what type of vehicle is in what in a parking spot, or like?
So two-wheeler parking spot will only accommodate two-wheeler vehicle, right?
Mm-hmm.
A four-wheeler will accommodate only a four-wheeler. So that's the,
Correct.
I mean, that should we should follow, right?
Oh,
So
so
this,
what we are doing is we are okay, okay, okay. So we are, I guess, what we are trying to do here is to make sure that a two-wheeler goes into a two-wheeler parking spot only and not in a
right?
four-wheeler.
Exactly. So we are
Okay.
using a vehicle on that basis, and
Okay.
then
Okay.
what's the functionality that does it provide? This two-wheeler parking, sorry, parking spot. So it will have its own getters and setters,
Mm,
right? And then apart from that, the functionality of this parking spot is to park the vehicle, whatever vehicle does it have,
mm.
right? And then we will see,
Unpark, park,
unpark the
unpark.
vehicle, yes. Unpark the vehicle, whatever vehicle it has come. So these are the core functionality that it will provide. Important point.
Mm,
Okay. So now this would be extended by two-wheeler parking spot, three-wheeler parking spot,
mm,
four-wheeler. So now we can extend as much as we want. So now vehicle, what all things the vehicle has? Its own ID or registration number, right? It should be of type string, registration, which is of type string. Then what else does it have? It has a license associated to that, right?
Hmm.
Vehicle, you tell me what all things generally a vehicle has.
A vehicle has a number,
Right, a vehicle has a
vehicle number.
number plate,
Hmm.
registration number of type string.
Hmm.
It would be registration of type string. Then what
Okay, so
else
there will
does
be
it
a
have?
registration of type string.
Hmm.
So vehicle would be a four-wheeler, two-wheeler. So it will have a,
Exactly,
yeah, identification for like the number of
right.
wheels
And
or like
exactly on the
the
basis of
category.
wheels, exactly. So it can be of two-wheeler, three-wheeler, and all that, right? So it will be of
Mm-hmm.
type vehicle type, which is of which is enum type, which will be two-wheeler,
Yeah.
three-wheeler. So and then this can be extended by two-wheeler, three-wheeler vehicle, or four-wheeler vehicle. Okay, so now we have designed about vehicles, parking spot. Now let's see what all things have been decided. Vehicle we have written, then we have considered about parking spot, and then let's talk about the entrance gate. Right?
Hmm.
Any doubts till now?
No, I
Okay.
don't.
So now at the entrance gate, just try to visualize what happens at the entrance gate. There is a vehicle that is comes right
So first we
now.
have to get the attributes of
Mhm.
the entrance gate.
Right. So there is
So
one more
gate
thing.
number or gate ID.
Yeah, right. So there is one more thing we need to be taken care of is parking spot. Who will manage the parking spot? Right. For example, at the entrance gate, we are going to assign a parking spot. Right.
I
At
mean,
the to the
like
vehicle.
we are. So are we assuming that there will be a person who is going to take care of that, or?
Right. So a person would use this software
Hmm.
to assign the parking spot. Assign parking spot to a
Hmm.
vehicle, right? What are the core functionality? It will assign a parking spot. How will it assign? It will find out which parking spot is left. It will assign. Then it will generate a ticket at the entrance gate,
Hmm.
right? It will give us the ticket, and what else it will do? It will find the spot, and that is it, right? Assign the spot and generate. These are the core functionality that it will
Hmm.
provide. So at this place, what all things will it have? Um, Entrance gate, right? It has the vehicle,
Gate ID
way
in case
gate
of
ID.
multiples. In case of
Yeah,
multiple, yeah.
there can be multiple entrances, right? Correct.
Hmm.
So entrance gate in because there are multiple entrance gate, right? So
Hmm.
entrance gate, this will have a ID associated to this, right?
Hmm.
Just a
Hmm.
normal ID that will help us to identify, and
Hmm.
at the ID a vehicle will come, right? So list of gate that you are talking, that will be there in the parking lot main system class. Okay. Then there
Okay.
will be also an exit gate, right? What is the functionality? It would be at ID, and then vehicle will come. What's the
Hmm.
functionality of this? It will unassign parking spot, right?
Hmm. Hmm.
It will unassign the parking spot. Vehicle will come, and it will
Calculate.
also calculate payment. Yes,
Hmm.
calculate payment. So let's list this down in a better way, just because these are the core components that someone has asked. So then it is having the exit gate. It will have its own ID. Then vehicle will come, and then what all functionality does it have? It will calculate the payment, calculate
Calculate
payment.
sign vehicle.
So for payment, it will should have payment object, payment
Yes.
this thing,
Hmm. Of the
calculate
payment
payment,
class.
and then so a vehicle will be coming, right? A vehicle should have a, I mean, it should have the this should have a
Assignment
ticket
number.
associated to it,
Yeah. Ticket
right?
number. Yeah.
So ticket should be associated to something, right? So we need to
Hmm.
now assign a ticket to vehicle, right? Someone should do this functionality. At the entrance gate, it will generate a ticket, right? And then it will also give me a
Hmm.
ticket and associate it to something like vehicle number this has ticket T1 V1, vehicle 2 has ticket T2, something like this,
Mm-hmm.
right?
Yeah.
So who is
So I
taking
think
that part,
there will be another class for ticket.
right? Who will take care of all that, right? So we can
Mm-hmm.
introduce a class such as parking spot manager, right, which will do
Mm.
our this functionality, right? We haven't designed the ticket class yet. Let's design a ticket class. So a ticket will have its ID. A ticket is associated
It's
to
an
a
ID.
vehicle,
So it will have
right?
a vehicle, like a
Now
ticket
we
will have
got
a
the
vehicle
mapping.
number
A
or
ticket is
vehicle.
having a vehicle,
Hmm.
right? Vehicle has vehicle number associated. So now
Hmm.
ticket, we have the ticket information. What all other things does a ticket have? Vehicle and then the
But it will have the
entry
type.
time,
Yeah.
right? Vehicle. These are the important this thing, and then the it
And
will
it will have an
ticket.
exit time.
No, that one we will calculate, right? After.
Yeah, but we'll calculate. But like a
Mhm,
ticket, we can have a exit time which can be null at the beginning.
mhm.
And when the vehicle exits out, we can
Yeah, we can
update
have that.
ticket in a system that says like, okay, this vehicle now
Yeah, we can also include that. This is of time, date, time,
that
type. We
time.
can also define,
Hmm.
right? Then what else does it have? Then it should ticket should also has a parking spot, right? Which parking
Yes.
spot is
Yeah. Hmm.
assigned to that, right? Which is of type parking spot. So now
Hmm.
important point: a ticket should be present at the exit, right? We need a ticket object
Hmm.
also. We don't need a this thing. We don't need a vehicle object. From the ticket we can assign, we can
Get that.
take
Yeah, we
out
can
the
get. Yes.
right. So just a minute. So at the exit gate we will have the ID. Then ticket will be given to us. From ticket we can this thing, right? Now
Hmm.
important functionality is to calculate payment, and ticket is having so payment object should also be needed over here, and then calculate payment and unassigned vehicle parking spot,
Hmm.
unassigned parking spot, right?
Hmm.
So now these are the methods that we are going to invoke. Now payment is another class over here which we are going to define. So in the question, payment was of less concern, right? So we will not
Hmm.
dive deep into it. So payment can be of ID, and this is
Type.
basically an interface payment, and
Hmm.
then whether the status is paid or
Why
not,
do we have to have it as an interface?
so that we can extend it via credit card and then
Okay.
via cash. Then we can,
So why not have like a
mhm.
abstract class for payment?
Yeah, we can include abstract class also. Okay,
So any difference
basically
between
generic class
interface and
kind of thing. Okay, so abstract class, and then
hmm.
credit card, cash, online, whatever mode we are going to pay, UPI.
Hmm.
Okay, so that can be payment. So don't deep in, let's not deep dive
It's
inside
not like
payments.
yeah, it's not important at the moment.
Yeah, exactly. So now
Hmm.
exit gate calculates this one, and then now let's revisit our requirement. Parking of vehicle, one or more entrance gate. We will touch upon this one. Entry ticket, exit payment. We have discussed user
Then I
and
guess
visit
user
user
might
part.
not be a separate class of its own because
Yeah,
we'll
because
get the
that is
user
a.
details from the like
Mhm.
we are not concerned about
Yeah, we are not
or
concerned
should
about user.
we can
Exactly.
include that user detail like okay in
Actually, there's no point of maintaining user details. If you see,
yeah
we are
yeah
concerned about vehicles, right, which we have
yeah
already done. Payment is also done, exit is also done, right? So we have covered most of the part. So now think from the client perspective. So now how are we going to use this class, right? There is no system. So now we will also need a system class, which will
hmm.
basically your parking lot class, main
Okay, okay, main. Okay.
parking lot, right? So what all things will it have? It will have a list of parking spots, right?
Mm-hmm.
Your system class, this is the main system class. It will have a list of parking spot. Then what all other things it will have? it will have a list of entrance gate,
Yes.
right?
Entrance and exit gates.
Right. It will have a list of exit gate because there can be multiple exit gate, right? Exit gates.
Hmm.
Then so this will having parking spot and list of entrance. So it will provide CRUD operations for above features. CRUD operations on above features. That means
Hmm.
addition of entrance gate, addition of exit gate. So all
Hmm.
this will be
Hmm.
done by the system, whoever is maintaining this one,
Hmm.
right?
Okay.
So now we are doing this also. What else is left? So now how are we going to use this, right? So
Right.
now how are we going to use this? So someone, if they want to use it, they can create a class of this one parking lot. And let's suppose, so how are we going to use it? We will create something like parking lot p1 equals to new parking lot, and now p1 dot add what all things is that we can add the parking spot. We can basically the demo class I'm drawing. We can
Hmm.
add
Hmm.
the exit gate and the entry gate. All this I have already added, so I have instantiated the parking lot now. So now after instantiating, a vehicle will come. Just a minute. So it will. There's one class that is missing. Who is going to basically connect the parking lot to the entrance gate, parking spot, and do end to end,
Hmm.
right?
Hmm.
So
Hmm.
who is going to do that? We have to create that, right? So for that, list of CRUD operations on our mm,
Can you drag your screen down?
down. Okay, CRUD operations on our features.
Okay.
Okay. Okay. So now these are the core classes that we have developed, and now we are going to uh, see how our function will, how our program will work. So now this is our demo class. Then we'll see. So what we will do is we'll create a singleton object. Generally, of the main core class, we create a singleton object. So
Hmm.
parking lot p1 equals to new parking lot, creating an object of parking lot.
Hmm.
Right
Hmm.
now, p1 dot. For example, our parking lot is already
Hmm.
instantiated
Hmm. Hmm.
with a list of parking lots, entrance gates, and exit gates. Okay, now a vehicle came. So now p1 should give a functionality of p dot park vehicle, right? Vehicle v1 I am passing.
Hmm.
uh, so now this park vehicle functionality is to find the spot, give me the spot, and then park vehicle, right? So parking lot should also provide me this functionality. So CRUD operations on above feature. Just a minute, let me write down. Do you get what problem I'm trying to solve? CRUD operation
Hmm.
on above. So what problem I'm trying to solve? Think from the client's perspective. So now, if you think this is complete or not, do you think is this complete?
Yeah,
Anything
I
left?
think this is complete.
hmm Okay, if you think this is complete, just tell me. I am the client. How am I going to use this? That means I have bought this software from you. Now I
Hmm.
need to use the park vehicle, unpark vehicle, calculate payment, and all that. How am I going to use it? I cannot directly call add payment and all that, right? I don't know your functionality,
Yeah,
whatever
yeah, yeah.
behind the
Hmm.
scenes you are
Hmm. Hmm.
doing. I need to expose the main class. I will just give an object of that class. From that object, you just call all the main core functionality, right?
Hmm.
Basically,
Hmm.
now
Hmm. Hmm.
the core functionality, just remember. So, what all core functionality we are need to provide? Park vehicle, right?
Assign ticket.
Unpark vehicle, sorry, assign
Entry.
vehicle, assign parking
Other.
spot, sorry,
Hmm. Hmm.
park vehicle and all that will be taken.
So if we so
Basically,
if we look at like so if we take the scenario where it has a car has just arrived at our entry gate,
hmm.
do we look into that or like, do we go line like that way or can we start from assigning a parking space?
I didn't get your question. Can you repeat?
So when we create these like when we give them the functions like the functions they can call
Mm-hmm.
right on the main like main class object,
Mm-hmm.
then how do we do it like should we use uh, what can I say?
We are going to use the service class that we have built, right? So for park
Mm-hmm.
vehicle, who is providing this functionality? Parking spot is providing this functionality, right? So
Mm-hmm.
parking spot, we already have the parking spot, right? So park vehicle, so list of parking spot I already have. So I will have a list of parking spot. So park vehicle, what it will do is it will get the parking spot on the basis of vehicle, and then what it will do, it get parking spot from the parks. Basically I have the parking spot object, right? List
Mm-hmm.
of parking spot, and now
So I guess
from
we
this
should
list.
also have a list of. So we should, I think, also maintain a list of uh,
Mhm.
occupied and unoccupied parking spots that can be returned.
Yeah, but that is already there, right? Parking spot has that feature, whether it's available or not
Okay, okay,
over
okay,
here.
okay, okay.
It's already
Mm-hmm.
there, right? So from the parking spot we can design. So now, for example, we can run a loop onto the parking spot, right? For this and onto this list, and then find it, right? So for a parking spot, basically parking spot PS in our PS, then if PS dot is available, if it's available, and vehicle is also of that type. If v dot
Mm-hmm.
type is of type whatever type parking spot has, then give me that
Mm-hmm.
functionality, and on that basis we will do. Now who will take care of this one is park vehicle. This parking spot will take care. I will just pass the vehicle to it. Okay, this functionality should be provided there. No, no, actually it should be here because from the list we are finding it here. So now basically park vehicle, then we will also provide unparked vehicle, right? So who is doing that? Again, parking spot will provide us this functionality. So we'll
Mm-hmm.
call ps.park vehicle and we'll just pass vehicle over there. Unparked vehicle, we will pass vehicle, then ps is basically the parking spot dot unparked
Mm-hmm.
vehicle. We'll provide the, then what else other functionality do we provide? Park, unpark, and then
Create ticket, like assign ticket,
right, calculate payment.
calculate payment.
We will also need the payment over here, right?
Mm.
So not payment, basically from the ticket we already we already have park vehicle and ticket exit gate already. We might have exit gate, yeah, we already have exit gate, right? So
Mm-hmm.
from the exit gate we can get the information about all that, right? What else is left? Now I think it should be
So in
p1
this
dot
class we are designing, so in this
mhm,
main class, the
parking lot.
parking lot class,
Mhm.
this is the main, uh, so this is the main class that we will be using. Not client will not be concerned about
Right.
the create how create ticket works
Right, or exactly.
and
Will
all
is
those
this
things.
the main class? That means this is how the
Okay.
client will use. We will just give an object p1 dot park vehicle v1 dot v1, and then p1 dot unpark vehicle,
Mm.
right? Then they will just provide v1, and the unparked vehicle will automatically unassign the all the business logic will go inside the parking spot thing. So it will just
Okay.
uh, do all the this thing, all the business logic over here. Unparked vehicle, we will just call parking spot dot unparked vehicle, that's it, right? And then for payment calculation, that part, let me check how are we going to use that part. So unparked vehicle, so yeah, so payment, parking lot dot calculate payment, it will give calculate payment, and then it will give the vehicle, right? No, ticket at the we'll just provide the ticket whatever we have been given to us, right? T1 dot calculate payment, so it will also provide one this one, calculate payment, right? And over here we have been given the ticket to us, and now what it, how do we calculate the payment? For that it will do exit gate has the calculate payment strategy. So exit gate object, let's suppose I have the exit gate object dot calculate payment, I will just provide the ticket that is come to me, right? And then it will give me the payment, right? Any other thing that you can think of? I think we have covered most of the thing. Parking of vehicle, one or
Yeah,
more
we, yeah. So
entrances,
I think the
exit vehicle. Any other doubts or any other thing you have?
So
Hmm.
yeah, I think we have covered all those
So,
functionalities.
mhm, okay. So that is how we approach a system design, low-level design. We just write
Mm,
down the components, we just devise the class, and at the end we devise a system class which will cater
mm,
to all our APIs that the customer needs. Then what we'll do is we'll
mm,
just instantiate a system class, and then we'll provide all the APIs so that they can start using it. So now the mechanic, whoever is using all our software, they will just call
mm.
park vehicle, unpark vehicle, calculate payment. What else? I think these are the basic
Yeah, this is
things,
the main
right?
thing. We go to a parking lot, we get a ticket from the
Hmm.
client's perspective, right?
Hmm.
We get a we are so a person is in the booth, or let's say the computers are doing it by themselves
Right.
at the entry gate, right? We get a car, we assign it a ticket.
Hmm.
So park vehicle is already handling those situations,
Right.
right? Yeah, so we our parking lot basically parks the vehicle,
Hmm.
it unparks the vehicle,
Hmm.
right? And then it generates some
Hmm.
revenue out of
So
it.
now, yeah, exactly. So now, if you see this park vehicle, right? Inside this park vehicle, what it will do is it will find a parking spot, and then it will give inside the ticket that this is the parking
Mm,
spot that you have been provided. That's the business logic we have to write it down over here. Park vehicle, and then if it's several, ps dot park vehicle. So now ps is parking spot. It will just park the vehicle over here, and we have to write the business logic. We don't go inside the internals of that,
mm.
right? So I think this is it from parking lot perspective. Any other doubts? So now you can